let's go one step further and make this a genuine roadster with a seamless removable coupe hardtop to where you could not tell it was just an aftermarket hardtop put on the car. So this design, in my belief, it carries on with the original AC Cobra heritage and many of the design uh, elements from the 427 Cobra, 289 Cobra, and the Daytona Coupe are all blended together in this design. So here it is with the coupe hardtop on. Side by side, we can see that I've given AC Cars a new AC Cobra logo, which I hope they use because it's an original logo and it brands the AC Cobra, which is their licensed name in the UK. So here we see the front and back views, both Roadster and Coupe. Now, all of these design renderings were based on my original design, which was a wide body, meaning the whole car is like 77 inches wide. And here we just see a view of what the ICE version would look like. So the monocoque chassis was designed to accommodate the 427 engine and transmission and drivetrain, and it was also designed to accommodate the full electric batteries and electric motors. So I'll get to that shortly. But this just shows that the car has the one-piece front bonnet. The rocker panels of the car are very wide and deep to accommodate single or dual exhaust. And the rear trunk, that is a quick release removable unit. And why is it removable? Because when you remove the trunk, then the coupe hardtop fits in its place. So there is a seam that follows the ridge of the rear fenders, and that seam is where the coupe hardtop and the trunk fit in. So here's a quick view of the monocoque space frame chassis. And the idea is to make this car as light as humanly possible while also being extremely strong. And I don't know if anyone's actually produced a aluminum monocoque made from aluminum honeycomb, but that was my instinct, was to utilize this lightweight rigid panel and furthermore inject the honeycomb cells with high density foam. So now you have a very rigid, very strong panel. And when you join vertical panels with the horizontal panels, and you have the aluminum channel for riveting the two together with structural adhesive, you now have 8 total I-beams that go into the monocoque. So this would be very light. And then the front and back has bolt-on subframe sections also made of aluminum to support either the engine and primarily the suspension towers. So here we have a overview of the BEV version. So in the rear, we have larger high horsepower motors. So you have 2 in the rear driving each axle. And in the front, you have an option of the same 2 large high horsepower motors or going to the smaller um, motor to where either choice you make, you're going to have a 4-wheel drive car. Now, the idea to make this car easier to produce with AC cars, current cars, is to reutilize the geometry and suspension from the 427 Cobra. Obviously, the front is going to have different hubs hubs and spindles because you now have to accommodate the drive shaft for the front wheel drive. So there's some engineering details that have to be worked out to be able to produce the components to create this new car. But with the ICE version requiring this very large transmission tunnel, because the engine is front midship as far back as possible, the idea was, okay, do we build two monocoques, one for the BEV and one for the ICE? And I thought, no, that's more tooling, more time. Let's simplify it. So the monocoque has one shared design. It's only the very front firewall where the footbox are that front panel would deviate in the design to have a angled turn to accommodate the transmission with a larger opening. But other than that, the side channels, the center tunnel, and the twin rear sections where the seats are mounted, and in the very front, in front of the foot boxes, those are all closed sections of roughly 4-inch height where batteries can fit in. So we do have batteries in the very center. We have them under the seats and in the twin side channels, and then also in the very front where the engine would have normally been placed. So the suspension towers, the monocoque, it all works together with either power plant to make this easier. So here we have a side view of the BEV, and it shows the 21-inch rims in the back, the 20 in front. It has the battery that you see, the long horizontal strip. That's representative of the side channels, the center tunnel, and the very front. So there's ample room in the front area for the control modules. And if you notice those little orange rectangular twin squares, that's accommodating a future ICE generator. So the ICE power plant is the lighter orange, closer to the front axle, and then the darker orange is the added generator. So the same motors that power the car can also be used as a generator. So a smaller Emmerich motor would be attached to the ICE power plant, and you could generate electricity and extend the range of the batteries when those units, that one unit is available. So the front of the car, the nose is actually a wing foil. So as the air enters through the car in front, it's routed through the radiator and through a aluminum chamber. So it's going to cool the batteries through the radiator, and it's also going to allow air just to pass through the car, helping to create downforce on the car. So that's the extent of the engineering. This is a quick view of the interior. What this does is it takes the same flat dash panel from 1965 Cobras, and we use the same Smith instruments. And AC Cars is working with the same vendor who's providing the instruments, and they have versions for the electric car, but they look just like the 1965 period. So this one has a couple of modern details, but it looks seamless with the design. To the left of the steering wheel is the fog light switch, and then the dashboard instrumentation light dimmer switch. Below that is the fuel door release, and then the front bonnet release. And then dead center, underneath the 3 round smaller instruments, you have a climate control electronic unit, but it utilizes the old toggle switches, but it has added international symbols and lights. So if you want to recirculate, you just press the toggle down. If you want fresh air, you press the toggle up. So on the face, it looks like 1965, but behind the face, it's all modern um, electronic climate control. And then under the dash, there's room for a fire extinguisher because it looks cool in Shelby cars. And in the center on the tunnel, it has the gear shifter. And then on either side is built-in armrests. And on the passenger side, you have a hand grip. So then you have the hand grip also on the door. So the passenger could have dual hand grips while you're screaming to 180 miles an hour fast. Here's a quick view of the car from the side with the top on and with the top off. And the other side of the car, showing more of the front end. So the lighting is all LED, brand new design. So the electric version would look identical minus the side pipe openings. And also on this car, trying to keep the drag coefficient as low as possible. Everything is as flush as possible. So even on the ICE version, the fuel filler is recessed below the top surface. The door handles are a unique design flush with the door. The only protrusions is the mirror and the side pipes and the front bumper jacks. The glass is all glued in place, except for the driver and passenger doors, which roll up and down. So here it is at night showing the LED lighting. So you have fog lights, you have daytime running lights, you have the high intensity lights, and the side markers and turn signals are part of the daytime running lights. There's switchbacks. So when you're turning, half of it's going to turn amber color. And just a note on the back, I don't think I added the back view on this, but where the taillights are, those are actually protruding LED fins. And that's to help the aerodynamics in the rear. And they protrude about an inch, inch and a half. This is a top view. So you can see in the back the triangular red. That's actually the fins that follow the contour of the rear. And then the hood has the dual vent exhaust similar to the GT40. And here it is with the top off. And you'll notice the twin roll bars in back. It's actually mounted to the rear subframes. And then you have the supports going inside the car, crisscrossing over the transmission tunnel, and then they go back up to the cowl, which is behind the dashboard. So you have an exposed roll cage, chrome plated or painted. So it just adds to the car and the racing heritage. Here it is without the racing stripes in black and with the bumper jacks. Kind of looks cool. And then I'm just going to show you what the car looks like in street form. So this is the SCRS for street. It would still have the roll bars, the internal roll cage, side pipes if it's the ICE model. But instead of bumper jacks, it has the Cobra chrome bumper overriders. And this is a nice color, Silverstone and Daytona blue, Le Mans blue, Indy red, and black. So this last slide is my my contact page if anyone wants to contact me. Okay, so Is anyone interested in seeing the actual engineering drawings?
Absolutely, yes.
Okay.
As long as there's no test afterwards.
Yeah,
No
please.
test. Let me open it. And
While you're opening it, have you done any CFD to look at drag and lift or downforce?
um, short answer, no, but I already sent out the line drawing drafts to a guy in India who was on LinkedIn who contacted me, said he wanted to participate in this. Carl's the one that actually said, "Hey, the best way to refine the design is to take a CD or a CAD model of the car and do testing." So my hope is that the drag will be in the coefficiency of 0.19 to 0.20. The original Daytona coupe was 0.29, which is pretty high by today's standard. And the Daytona coupe had a lot of things protruding from the body. I mean, all kinds of things. And so uh, that is something that has to be done. So that's in the process. Okay, so let me share my screen again. We're going to go over the drawings real quick. Okay, so I'm going to give you a quick overview. That's too big. Okay, so we have the top view, we have the side view, and we have front and back. So now in those color renderings you saw, I told you it was the wide body. So after much debate and realization that in order to keep the target weight of the finished car, whether it be the ICE or the BEV, I have to reduce the width of the car. So it can't be as mean and aggressive looking. So the front end is now 72 inches wide, whereas the back end with the flared bigger tires in the back, those are 75 inches. So in order to come up with the street model and the SC model, what I did was came up with two different sets of wheels. So I'm going to show you the narrow version. So I just have to scroll through countless layers. Go S body and S coupe. Okay, so this one would be the street model. So the street model has 19-inch rims and all four rims are identical. But to maintain the good look styling of the car, especially in the back, because the back end is much wider, you can see how I moved the 9-inch rims all the way out to the edge of the back of the car. Now, the original 427 Cobra, they only built a limited amount of SC models and racing models. They didn't need very many. So they tried to sell the surplus racing models as semi-competition SC. And the street model had all four rims being 7.5 inches, but the rear rims were inset way far back, which made the bulging fender flares look funny because it didn't fill out the wheel well opening. So rather than build two different bodies, one for street and one for SC, I just said, okay, we'll take the same rims from up front and move them outboard more. So you can see how it still fills the wheel well openings in the back and the front. So now let me switch back to the SC model. SC. And SC rims. As soon as I'm done tweaking this design, I'm going to separate the SE model from the S model, but for now I have to toggle between layers. So in the rear, the tires front and rear match the current Porsche 911 GT3. The wheelbase is a bit longer, and this wheelbase being at 100 inches is actually 10 inches longer than the original Cobra. So if we were to look at the cockpit on this car, you could see how we're accommodating a 6'1" or a 6'0" driver. You got almost as much headroom as a Mercedes E-Class or S-Class. You have the same 42-inch legroom, and the seats are 11.875 inches apart. So you have dual armrests, and then the contoured door panels have armrests and grab handles. So it's not anywhere near as cramped as the original Cobras because they were very small, lightweight cars. So this is designed to be more comfortable, but yet still as fun as the original Cobra. And now let me go backwards and start on the engineering layers. So the first one is monocoque. So on this monocoque, you can see up front where there's an opening for the transmission tunnel. So this would be the two panels in the very front that would have to turn at an angle to accommodate the transmission. And subframe. So front and rear is aluminum box channel rails, smaller on the latitude ones. And from those two subframes, you would mount the suspension towers. And then where the subframes meet the honeycomb aluminum, you have inner and outer plates. You're going to bond it with the structural adhesive and then bolts all the way through. And then if we added the suspension towers, so we have similar designed suspension towers as the 427 Cobra chassis. And you can't do the X brace like the Cobra had, so you have an upper support beam that links the two towers together. And then if we were to add the 7-liter engine, you can see how the Cobra chassis and transmission differential all fits within that tunnel. And I decided against the twin exhaust pipes. They should be the single 4-inch because that would fit within the side channels easier. And this just shows side view how it fits. So throughout the car is 5-inch clearance minus these two little rails under the car, which is 1/4 inch thick. And those two pads, there's actually 4 pads, they're mounted under the monocoque floor right here, 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 and here. There has to be some way to jack this car up on a lift for service. So I added those plates below the car. Now below the car, it would look like this, where the entire bottom is sealed and flat. So the aluminum monocoque floor would be one single piece of honeycomb die cut to this shape. So then you would have lighter gauge aluminum rear section and front section, and then the whole bonnet would tilt. So let's take off the engine and put in the hybrid. So you've seen this picture in the PowerPoint. It's basically the same monocoque, but these two angled sections of the tunnel will now go straight across. I had the layer done, but I don't think I saved it and it disappeared. So the motors for the electric version are close to the suspension towers. These could be adjusted inward more or less depending on if you do a gear reduction attachment to the motors or not. But there is ample room in the trunk for a spare tire. Let me see if I have that shown. There's the spare tire, and it fits very tightly, but it fits. And if we added the roll cage and the space frame, I have to readjust the space frame points because I reduced the car. But you have an internal roll cage on the doors, and then you have the external frame to support the aluminum skin, and the front bonnet has a X brace to keep it from warping. The rear has mounting points for the bumper jacks, and it even has a subframe for the coupe hardtop. So this is lighter gauge aluminum tubing, similar to the original Cobra cars. So everything I've tried to think of as much as possible to engineer this like the 1965 cars, but with some more innovative features like a roll cage inside being chrome plated would look super cool. And then hidden in the door is a horizontal piece. So this is offering full protection for racing or even for street use. So it's a lightweight car still, but it has a built-in roll cage for protection. So that pretty much concludes the presentation. We're still working on the powertrain options, the motors, the battery pack. But the way it looks right now, if we were to use lithium-ion batteries, then we have room for 58.2 kilowatt hour battery. So if the target weight of the car is as anticipated, then the street model BEV would weigh about 2,600 pounds, and the SC model with the larger motors, that would be about 2,800 pounds. So in comparison to a Tesla Model S, that car weighs almost 5,000 pounds. So this is almost half the weight. And if you still introduce, like let's say the street model with all four motors being the smaller MRX 286, then you still have 508 horsepower that's continuous, 628 foot-pounds torque continuous, and these specs would be slightly better than the 1965 427 Street Cobra. Now on the SC model, Carl suggests we can go two ways. The larger E motors in the back and the smaller E motors in the front, or if people really want to spend the money, all four motors would be the larger MRX 348. So if we split the two small and the two large, we would still have 538 horsepower continuous, 732 foot-pounds torque continuous. And that's not including the peak for like a maximum of 5 to 10 seconds. So if the buyer wanted all four larger motors, then this would be closer to 1,000 horsepower, similar to the Tesla. But on a car that's half the weight, I don't think you need 1,000 brake horsepower continuous because you're more than likely going to lose control of the car and possibly regret it. So that concludes that. Does anyone have any questions?
Yeah, this is Brian. Are those cooled batteries? Are they air cooled or liquid cooled, or do you know yet?
There's three options with Emmerich: air cooled only, liquid cooled only, or liquid and air cooled. Now, I was reading a little bit about the Emmerich's motors, but I'm leaving all of that to Carl because he's the propulsion engineer, and my specialty is design and creativity. I do love engineering, but that's beyond me. But Carl is suggesting liquid cooled only. It has slightly less horsepower than the air and liquid combination, but Carl says the whole motor's in a better state if it's just liquid cooled. And so the other considerations was we're going to use the low voltage, not the medium, not the high. It would have a 1 hour charge time, slow by today's standards, but the battery is going to last a lot longer. And um, I trust Carl's decisions on the powertrain. Now, right now, AC Cars is working with their own vendors on their electric powertrains. And so I told Alan at AC Cars that I have a propulsion engineer who would be an asset to the co-engineering of this project. And so, I mean, for now, it would have to have lithium ion batteries because that's all that's truly available. But I mean, solid state batteries are just around the corner. So we could clearly remove a couple sections of the batteries and yet still have the same range and lighter weight. So considering how AC cars, they currently have the AC Cobra 427, the 289, and the Ace. They're all electric, but what we're proposing is even better than what they have. And the Emmerich's motors are small, you know, and so you could technically put them inside the rim if you want. But you know,
Yeah.
I don't have all the engineering details for what is the exact best solution, but you know, it's like I know boat design that you want all that weight right in the dead center of the boat, like a sailboat. And you want
Yep.
a very heavy keel because that keeps the boat from tilting over. But now on a car, Carl's saying, well, it's not the same on a car or an airplane, you know. On the car, because you're going high speed turns, you want more weight outboard. You know, an airplane and a boat, you want the
Mhm.
weight inboard, you know. So that's a different thought for me because it's like, okay, you know, I'm not used to putting all the outboard weight because even all the auto journalists say you don't want weight way outside, you know, unsprung weight. And you want carbon fiber wheels because it'll make the EV car faster, more efficient, longer range. And so um, it depends on how far the project goes, you know, but yes, I would love to see carbon fiber rims in the same design to keep this car well below 2,800 pounds, closer to 2,600 pounds. And if you can do that and it be fully electric, you know, you're going to have a stellar car, you know, that's not extremely out of reach, you know, because of all the high tech. So like You saw the cockpit design, the body design. It's trying to capture 1965, and the kind of buyer for this car is going to want that old feel of the classic sports car. But they're going to want certain modern conveniences like I want, adequate leg room. I don't want to be squished against the door panel, and I do want power windows, power door locks, heated seats, that's going too far. But, like when I had a Zoom meeting with Alan after I sent him the initial design and presentations, and we're like in common agreement that yes, that's what you want to capture. Because the buyer for this car is not going to be, you know, he's going to buy it to enjoy it, and to kind of capture some of that old world heritage from the 60s. And so, like the climate control, on the surface it looks old, but the whole unit you don't see is all electronic, modern, would control all the heating. You'd have all the adequate heating and ventilation that the car needs. And you would also have defroster. And the rear hatch, all the glass on the car, I'm specifying to be Gorilla Glass, which is even smaller than quarter of an inch and much lighter, you know. And so the windscreen would be glued in place, and from the inside of the car, you would see the 1 inch aluminum tube substructure. And in the back, you would have the lift gate of the hatch that's opening independently, in addition to the whole coupe top coming off. And it would just have like the coupe would have 6 quick release points, which would be very easy. It could also be engineered to have it be hydraulic or electronic release to where one button would release all 6 points. But it's a fairly straightforward process of just, a quick unlatch 6 points, 2 points on the trunk, and you have a very simplistic but refined car. So that's the design parameters, goals.
So do you remove the boot lid before you put the
Yes.
coupe lid top
Yeah.
on?
There
Okay.
would be a very small jog between the boot lid and then that one little panel behind the seats. Um,
Mhm.
but the rubber seal underneath would hide the jog. And so I didn't show the option, but Carl said, but it rains a lot in Washington. I want a canvas top. I said, okay. So I did design a canvas top option. It doesn't have the quarter windows that Carl wanted, but it has the glass rear window, and it can
Mhm.
all fold up and go behind the driver and passenger seat. And it has that panel like the Mercedes SL, where it tilts up and then the top goes down and then you close the lid.
Yeah.
And it would still work with the roll bar design. Now, on the original Cobra 427, if you could see this,
Yeah.
you had the roll bar going the opposite angle and the support was going toward the trunk. So putting a tonneau cover or soft top was a challenge. And you could
Mhm.
not remove that panel behind the seats to get a onboard permanent canvas top to go up and down. So that's why the roll bars on the SCR is going the opposite direction, because it still has access to that panel behind the seats for optional canvas soft top.
I had a quick question if I could cut in here.
So you're the young guy.
I am, yeah, I'm a friend of Carl's. My name's Giuseppe. Good to meet you. I was curious, I think I got a little in the weeds, but talking about the the aluminum tubing that looks like it's a support for the body. or some of the shape of the body. Is that also foam filled, like honeycomb substrate, or is it just those 4x3 panel sections?
Okay, I don't have a picture that I could show you real quick, but the original Cobra had what Carroll Shelby called 4-inch sewer pipes. And it was just 4-inch steel tubes and then cross pieces to form a ladder. So they called it the ladder frame. And then that ladder frame supported the engine and the front and rear suspension towers. And then the whole entire aluminum body had a substructure, which was light gauge steel tubing. So only the cockpit interior panels, the wheel well, and like the body was aluminum. So it was aluminum over steel substructure. So the idea with this was let's make everything aluminum except for the roll cage. So the roll cage, I had it shown in yellow, and the yellow signifies chrome moly tubing.
Oh, okay.
And then all the other round tubing in blue, that's aluminum.
And that's just, yeah, there's no foam inserts or anything. That's
No.
just the straight in. Okay.
I was talking to Carl and I said, Carl, actually I contacted a honeycomb supplier first, and I go, do you have honeycomb that has high density foam injected in the cells? And he goes, it's out there, but we don't do it. He said, but yes, it's there. And he goes, why would you want injected foam? What's the application for this? I said, well, it's for a car. It's going to be the monocoque chassis. And the only fear I had with honeycomb is like, what if you jacked up the car and you accidentally put the points wrong? You know, it's going to go right through the honeycomb material. But then I was reading the news about this recent freeway shutdown in Virginia where all these people are stranded in the snow, and how electric cars, you know, didn't handle it so well. I thought, well, the more rigid that aluminum honeycomb is, it's going to be more rigid, so it's not going to likely dent as much. It's going to maintain more strength. And it's also going to insulate really well. Already, the aluminum honeycomb is already insulation advanced. It's also fire retardant. So it has many benefits, but adding the high density foam just strengthens it more and insulates it more. And then when you sandwich the battery packs on top of that floor, providing you add the I-beam lateral pieces, verticals, and you have the joints riveted and bonded together, you're going to create a substructure that's aerospace worthy. And then
it's a clever idea. Yeah.
And if you put the same aluminum honeycomb on above the battery packs, you know, that one only would have to be 1/2 inch. I specified 3/4 inch for the monocoque, but the top caps to the covering the batteries could be 1/2 inch honeycomb. So even if it did catch fire, you're going to be much safer. So
that makes
I
sense.
don't know if anyone's built an automotive monocoque out of honeycomb. I've heard talk. You know, one guy on the GT40 blog website was saying, I want to do this, but no one's ever heard of it. And AC Cars is like moving totally into 3D printing, carbon fiber bodies. And then the thought came to my mind, like, AC Cars, the builder of the original Cobras worth millions of dollars, can't go carbon fiber. And it's like, it has its pros and cons. But if we looked at just the monocoque, like McLaren Racing is using carbon fiber monocoque tubs. A lot of people are going carbon fiber. They think it's superior, but there's a company in England that's doing GT40 continuation replicas, and they offer three choices: a space frame chassis substructure, an aluminum monocoque, or a carbon fiber monocoque. Okay, so what's the difference between a carbon fiber monocoque versus aluminum monocoque? Well, the difference is $10,000. And the weight saving, a paltry 100 pounds. Now, the way this monocoque is designed, it's all flat pieces. There's no curves, no bends. It could basically be like a Lego set. And I designed two different joints. One is where it's truly like Lego, where it's got the T channel and L channel that are one piece design, and the only challenging part is to apply the structural adhesive in the channel, then drop in the honeycomb panel, and then, drill and rivet down the line. But the two-piece channel, inner and outer, is allowing for seamless adhesive application, then the riveting together. But that process is not as labor inducive as building the whole carbon fiber monocoque.
Yeah, that makes sense. All right, thanks for clarifying.
I'm thinking like a non-engineer, like how do you do this really simple? You know, like yes, a carbon fiber monocoque tub is beautiful and complex, but required a lot of tooling. You had to build a model mold, then you can lay up the parts, and repairing carbon fiber is more labor inducive than repairing an aluminum monocoque. So again, the idea of, like in boat construction, old boats were made with solid wood bulkheads, and the wood bulkheads inside the boat is what gave you the strength to support the mast. But now with high density foam, they're building ribs out of the high density foam and then fiberglassing over the foam, and you have built-in permanent ribs. And the idea of going aluminum honeycomb is even better because it's really light. And then if you inject foam in it, it's really light, but it's now even more rigid. And so the thought, I'm just sold on it. So I thought about this when I was talking to AC Cars. It's like the mind just says, no, a Cobra has to be aluminum, because do you realize what skill it takes to hand form an aluminum body, especially like a Cobra body? It's a dying art. People are forgetting how to do things simple by hand. Everyone's relying on computers, robotics, CAD. Carl's saying, oh, it's going to take 10 years for 3 people to engineer every component on this car. And I go, are you kidding me? We don't have 10 years. We have 3 months. If Shelby could build the Daytona coupe in 3 months, and if Jaguar could build their 1950s race car in 10 months, build a wood buck using ribs for the body design, hand shape the aluminum on it, then you've got your first plug. You can then make a mold off of that and make carbon fiber bodies. But I'm an old school. I like the aluminum because it's rare and it's harder to do.
Yeah, but it'll be interesting to see how that honeycombing shakes out. It's a cool idea.
So what's real interesting is, before I contacted AC Cars, I contacted Cobra in Utah, and I was telling him about this prototype I want built, and he says, "Oh yeah, I'll love to do it." So it took me a year of designing to where I finally said, "Okay, I'm done. I like this. No more changes." And then I finally get ready to send him the final and say, "Okay, when can I fly out?" And then he suddenly changed his tune and said, unless you have $5 million up front, I don't want to talk to you. So then I was going to get depressed and quit. And then I said, wait a second, what about AC cars? They built the original Cobra. And so I emailed him and he got a response. I got a response and he says, do you know how many people send me design ideas? But yeah, I'll take a look at it. And then lo and behold, he's interested and he says, yes, we can do this. So I have to now send him the final production design so I have no more excuse and so we can build this. But I wished I knew CAD, because then I could be even more precise. I'm drafting on the computer the way I would if I had a board and mechanical arm. So it is much harder, you know. But I think there's ways to build this car quick using technology. Like some of the suspension pieces could be 3D printed in aluminum. Um, there's a lot of use for 3D printing, like the whole LED headlights, taillights, those could be 3D printed. I put the Lucas brand on all the lighting because that was the British component, for all British cars, including the Cobra. And I use the Smith gauges, but some of the gauges are brand new design. It's just a matter of talking with these vendors from England and saying, can you do this? So this project needs a CAD engineer who can quickly look at this and say, well, yeah, that makes sense, or no, it doesn't make sense. I'm just guessing, from an artist standpoint with an inquisitive mind, I think it's going to work, but that's the way it worked in Carroll Shelby's days. He had a small garage shop in Marina del Rey. He had about 10 guys who loved tinkering with cars, hot rods. He gathered these people together and says, hey, we're going to build Cobras. The bodies and chassis are coming from England. We're just going to drop in Ford engines. We're going to tweak them. We're going to win races. Okay. So then Shelby says, I want to win international racing. So he tells Pete Brock, can you design a coupe body for this that will go faster than 165? And he goes, yes. And so he stole ideas from the Germans who were studying aerodynamics. He came up with the cam tail on the back of the car, and they did it in 3 months. But they didn't design a whole chassis from scratch. They had to, by race rules, reuse the existing chassis and drivetrain. You could just switch the body. So yeah, I could see how you could do the body in 3 months, but it wasn't a finished perfect body. It was a rough. Then they sent the design to Italy, a coach builder, and they built 6 more units. And what was funny was unit number one from Italy, they looked at the design and said, I think they made a mistake because the front of the windshield was low, and then where the head would be in the car, it was high. So it was slanting down in the front. And they go, that's not normal. The windshield's got to go up 2 inches. So they did it. And then Pete Brock saw that and he goes, what did you do? That's not how I designed it. I want the windshield 2 inches lower, like I told you. So surprisingly, that 2 inch higher windshield face slowed the car down by 5 miles per hour. And so that's the normal design even today. The Porsche 911, it's tall in front, slopes down in the back. So on this car, I lowered the front of the windshield even lower. So so that's the SCR, Super Coupe Roadster. So any other
Very
questions?
cool.
Carl and I are ready to build this thing, right? And Carl's model's going to have the wire wheels.
Spinners.
Yeah.
Brian asked a question before about cooling.
Oh.
I thought I heard Brian say batteries instead of motors. Is that what you meant?
Yeah, I was wondering about the batteries. Are they air cooled or liquid cooled? Also, I was curious about the motors too, so I was happy to hear that answer.
The reason why the water cooled motor had was a preferred choice was because
Right back.
it had IP67. What do you call it? Weather protection.
Environmental protection. Yeah, sure. Yeah.
Whereas the air and water cooled gave you a little more horsepower because you kept the things cooler, but it was only like 57, I think, or 53. You know, now the motor's exposed to the elements on the bottom.
Mhm.
So if the guy drove over a big deep water puddle, flood a street or something, I just felt more comfortable if the motor was 67.
Yeah.
67, you know.
Yeah. Yeah, for sure.
And you're only losing about I think it was about 12 horsepower. I think. You know, when you have 5 to 600 horsepower, I think we're okay. But anyway.
Yeah, when you get into racing, I suppose every horsepower matters and every pound matters. But
Right.
Until you get to that point, yeah, you can work a little bit more approximately.
For the people that want to race this car, usually tracks are dry, you know, and even if it's wet and when it's raining, it's very little water. It's not much. It's not a like thick puddle or driving through a stream or a lake or something. So then you go for air and water cooling. That would be fine, you know.
Yeah.
The battery packs right now using existing commercially available batteries. We can only get about maybe a couple hundred miles on the pack. But I'm working on some new batteries that'll be able to charge at least 50 times faster than the existing lithium-ion batteries. So you can pretty much pull up 5 minutes, you know, you're ready to go again. A lot faster than gasoline even. When you're driving, I know when I drive 3 hours, I'm ready to take a break. A lot of people are designing, so I want a 1,000-mile car. Well, there are enough charging stations nowadays, you know, between Tesla and VW and a dozen other charging suppliers. You can find a charging charger almost anywhere you go across the country, you know. And I used to drive from Olympia down to LA nonstop, except for getting gas, you know, and that was a good, healthy 17, 18-hour drive nonstop. Uh, Most normal people wouldn't do that, you know. So a guy who buys a car like this will most likely will not do that, you know, unless it's a big hurry. So, but anyway, the future batteries will be much higher specific energy, so that you can have much higher energy storage per pound than what it is today, you know, and you can charge a lot faster too. Tesla battery, they use the supercharger. They say I think 45 minutes you can get pretty much a full charge. That's true, but the problem is when you keep pushing it like that, lithium-ion chemistries, you tend to degrade the chemistry faster by charging it too fast. You know, I have batteries that you can charge in about 15 seconds if you wanted to, but you don't have much service life with that.
Yeah, you got about 1,000 cycles and then they're done.
Less, like maybe 200 cycles, you know.
Oh, really? Okay.
They have RC, you know, the drones, the RC.
Oh, yeah.
Airplane. They have them at 90C. 90C means 90 times the amp hour.
90C.
90C, yeah. They want these helicopters. They want them to take off like crazy. They're lifting up my remote light here. They carrying a lot of load and they want to take off vertically very fast. So they need a lot of juice. But you're getting about 200 at best, you know, cycles out of those batteries. But those fellas, they don't care. They just want to have fun. But for people who own cars, if you're going to replace a battery pack, that's more than a few $1,000s. You know,
Oh yeah.
I think Tesla is charging what $20,000-$30,000 or something like that for a full new pack. Price has been dropping quite a bit, but it's going back up again now because of the raw material cost recently, because of all this COVID stuff. But the new batteries that everybody's working on, including myself, will be a lot less expensive because we're not using lithium anymore. We're not using nickel, no cobalt.
Oh,
Okay.
good.
It's just aluminum and graphene. Graphene's carbon. Carbon is cheap.
Okay. Okay. Yeah.
So,
Mhm.
and even if the service life is only as much as a Tesla battery, which is like 4,000 cycles, that's fine. You know, if you charge it every day, get a full charge every day. So you divide 4,000 by 365. That's still a pretty good time. And the price would be like less than half of Tesla batteries, maybe a lot less than that. So, and it's recyclable too. Whereas lithium ion batteries is very expensive to recycle those things,
Mhm.
you know. And once you get away from cobalt and lithium, which is still pretty expensive, you're going to be saving a lot of money. Aluminum is really cheap, right? In comparison,
Mhm.
it's also lightweight. And if you can charge it even 20 times faster than lithium, most people will be very happy. You know, today people say, well, I want to be able to charge in 3 minutes. All right, it's doable. We have batteries today you can do it in 3 minutes. You know, I got batteries like that, but they're larger and heavier. They're not as they're more bulky. Okay,
And tremendously expensive.
and more expensive. Yeah, about double the price. Um, I was just telling Russ, you know, I was designing a GT40 using this super fast battery with some really very powerful electric motor that's very lightweight. On paper, I designed it so that it can beat the world record, you know, 0-60. At one time, the Roadster 2, Tesla Roadster 2, they were at 1.9 seconds, 0-60. Okay. I don't know if any gasoline engines can do that. But um, anyway, I think the fastest the gasoline engine can do is like 2 or 2.1 seconds, I think. I'm not sure. But recently somebody broke that record. I think they're down to like 1.8 or something like that now. You know. So
Wow.
the whole point is that with the new batteries, you can do that. It unleashes the electric energy, the juice, much quicker because internal resistance is lower. So you can pour out a lot more juice. And horsepower in an electric motor is all about juice, how much electric current you can put out. So
Mhm.
right now we're only at the tip of the iceberg, you know. So with the improvements of electric motors and batteries, these electric cars are going to be unbelievable. The electric flying cars will be coming around pretty soon. um, anyway.
Yeah. So, Russ mentioned that you went with lower voltage. What voltage are you planning for the motors?
Um, this particular motor company has a motor that can go up to 800 volts, but the horsepower output is lower. The lower voltage, which is higher current, the current gives you the juice, gives you, you're looking at about, I think, 300, roughly 300 volts, I think.
Hmm.
As we
Okay.
talk, we can take a look at the specs here.
Yeah.
But it's low enough so that we're going to have heavier cables for the current. But
Mhm.
if we can design it so that you minimize that length, you're only gaining no more than 50, 60 pounds for the extra cables, you know, for the extra juice. Even 100 pounds. We can even go to copper bars if we really had to. You know, but
Yeah. But the heavier cables get harder to route too. Their minimum bend radius
um,
grows a bit as well because you got to at roughly what 450 kilowatts of output and 300 volts. That means you're at what 1500 amps you have
mhm,
to run through there. So that's a
mhm.
lot of cable.
Right, right, right. Um, I don't, it depends on the buyer's option. We can offer options where if the guy's gonna be driving like a maniac all the time, he's gonna be in the track all the time racing, then we'll provide larger cables for him to do that. I used to design high voltage and high current coils using water cooling. We have very, very high speed deionized water to cool the coils. We were pumping like 22,000 amps through these copper bars, at 22,000 volts. So that's a lot of juice going through that bar.
Yeah. Wow.
Keep it cool. So this is all doable, with what Russ is designing here. We have a lot of leeway in terms of weight. The chassis he's designed is very lightweight, very stiff. And I'm hoping the newer batteries will come in fairly soon to reduce the weight. Most people don't really need a 1,000-mile battery. 200-mile batteries is fine because the average daily commute is like 40 miles. And for leisure driving, it's probably not more than 100 miles a day, weekend leisure driving. Even if it's 200 miles, you have to stop sometime to go to the bathroom or get something to eat or something. At that time, you just get it charged up. So, I don't want to steal too much time here from Russ, but if you guys have any more questions.
No, it's been a very, very fascinating presentation. I really appreciate you guys sharing that.
Yeah, we're also starting losing people, so it gets a little bit late. Well, thank you very much, Russ and Carl. Can we get a copy of that presentation to put it on our website?
Yes, Carl has it. He'll take care of that.
Okay, that is absolutely great.
Manfred, did you record the whole session?
I think I hit the button a little bit too late, but I'm still recording. So I think I have to review it, but I got 95% of it. So that's the other thing too. But I mean, depends on if somebody wants to sit through the recording or if somebody just wants to glance over the presentation. No, this is very, very interesting. And so thank you very much for taking the time, and we'll see you sometime in the future.
And thanks for the invite.
You're welcome. Take care. Bye-bye.
Right, thank you.
Bye-bye.
Bye-bye.
Bye, everybody.